kita harus memakai produk yang berkualitas, reusable, dan dapat bertahan lama.
Oh, kalau ini kita harus lakukan riset kan sebelum beli produk, karena agar kita tahu apa dampaknya ke lingkungan kita.
Iya, bener banget Ian. And lastly, kita harus mematikan AC, lampu, dan produk elektronik lainnya jika tidak digunakan.
Wah, banyak banget ya tipsnya.
Iya, emang banyak banget. Tunggu apa lagi? Yuk, mulai dari sekarang. Apa kamu masih ingin tahu lebih jauh? Tulis pertanyaanmu sebanyak-banyaknya dan nantikan Q&A session dengan narasumber keren di postingan IF selanjutnya. Ian, bentar deh. Tapi narasumbernya emang siapa aja sih?
Jadi ada 3 nih narasumbernya. Ketiga narasumber ini akan menjawab pertanyaan teman-teman semua.
Ada Mbak Indira, peneliti isu less waste.
Nah, ini Mas Nailul, Ketua Himpunan Teknik Lingkungan 2020.
And last but not least, Ibu Vita, penganut gaya hidup less waste.
Keren-keren kan ya? Mantap dah IF.
Jadi teman-teman, tanpa kita sadari, kebiasaan konsumsi kita telah mempengaruhi keberlangsungan alam.
Nah, banyak hal-hal kecil yang bisa kita mulai lakukan untuk memperbaiki kebiasaan buruk kita maupun orang sekitar kita.
Jadi, Ian, udah siap belum ngerjain quiz minggu ini? IF Quiz kali ini menguji kemampuan membuat keputusan teman-teman terhadap kebiasaan konsumsi loh.
Frida, denger-denger ada yang baru ya tentang IF Quiz minggu ini?
Bener banget. Penasaran kan? Yuk akses quiznya melalui link ini.
Nah, di sini berarti yang salah bukan plastiknya, tapi penggunanya.
Ada Mbak Indira.
Iya, Mbak Indira di sini sebagai narasumber yang akan menjawab pertanyaan teman-teman semua.
Bentar, intro dulu.
Halo teman-teman, kembali lagi bersama kita, Frida.
Dan Ian. Jadi kita ngapain nih?
Jadi, kita sekarang mau dengar jawaban dari 3 narasumber kita.
Oh, waktu open Q&A session ya?
Iya, yuk sebelum itu kita kenalan lagi sama narasumber kita yang keren-keren. Pertama, ada Mbak Indira, peneliti isu less waste.
Kedua, ada Mas Nailul, Ketua HMTL 2020.
And last but not least, ada Ibu Vita, penganut gaya hidup less waste.
Oke, mari kita simak jawaban dari beberapa pertanyaan kalian.
Mbak, apakah kita sebaiknya lebih mengutamakan pemakaian produk eco-friendly atau produk yang bertahan lama? Jika kita diberikan pilihan untuk memakai suatu produk yang ramah lingkungan tetapi tidak bertahan lama atau produk yang kurang ramah lingkungan tetapi tahan lama, mana yang sebaiknya kita pilih?
Untuk ini sangat tergantung dari life cycle atau siklus hidup produk itu sendiri. Jika butuh yang disposable atau yang sekali pakai, pilihlah opsi yang eco-friendly. Namun, jika memang barang tersebut bisa digunakan berkali-kali, pilihlah opsi yang reusable. Teman-teman juga bisa loh memilih produk yang eco-friendly dan reusable. Contohnya adalah membeli tempat minum dari bambu. Ketika mereka sampai di landfill atau tempat pembuangan akhir, dampaknya juga akan lebih sedikit kepada lingkungan.
Mbak Indira, aku ingin tahu. Dulu, plastik digunakan untuk menggantikan pemakaian kertas terlalu banyak yang mengakibatkan deforestation. Ternyata, plastik juga memiliki dampak buruk, yaitu dari segi waste-nya. Jika kita sudah beralih dari plastik, apakah hal ini akan terulang? Bahan apakah yang sebenarnya yang dapat menggantikan penggunaan plastik yang benar-benar efektif dan ramah lingkungan?
yang salah bukan plastiknya, tapi penggunanya. Plastik sebenarnya memiliki waktu hidup yang sangat lama, hingga 500 tahun. Tapi perilaku manusialah yang memendekkan siklus hidup tersebut dengan langsung membuangnya. Jika teman-teman ingin berbelanja dengan kantong plastik, sebenarnya tidak masalah, namun teman-teman harus menggunakannya berulang-ulang kali. Teman-teman sudah tahu kan sekarang banyak sekali inovasi seperti kantong plastik dari ubi dan juga
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to guest lecture series on SDGs today, Tuesday, 29 September 2020. I am Fitria from ITS Global Engagement and will be your master of ceremony this afternoon. Thank you for joining our guest lecture series on SDGs today. Before we start our agenda, let me inform you of some rules for the event. First, please adjust your name or ID screen using format institutions_name. Second, during the lecture, please turn on mute mode and only turn on the audio when the moderator gives the chance. Third, please fill your attendance at bit.ly/attendance_GLSSDGs. And our committee also sent the attendance link in the Zoom chat room, and the link will close in 15 minutes from now. Fourth, participants who wish to ask questions during the question and answer session, please send your question to bit.ly/question GLS climate change. The link for questions list in the chat room too. Or you can ask directly by clicking the raise hand feature. Ladies and gentlemen, this guest lecture series on SDGs is dedicated as a form of appreciation in commemorating the 16th anniversary of the Institute Teknologi 10 November Surabaya. This event is held every Tuesday, delivered by speakers from different countries who bring a very interesting topic. So, don't miss it. Stay tuned. And today's lecture's theme is climate change, which will be delivered by our speaker, Professor Sambit Datta from Curtin University, Australia. The lecture will be moderated by I Gusti Dewa Ayu Agung Warmadewanti, ST MT PhD, as Head of Center of Research for Infrastructure and Sustainable Environment, ITS. Before we proceed to the next agenda, allow me to deliver our schedule today as follows. First, opening speech. Second, lecture. Third, question and answer session. Fourth, certificate awarding. Fifth, closing. We are now going to listen to the opening speech delivered by Associate Professor Oktavianti Dwi Wahyurini, ST MF Des Arts PhD, a Senior Manager of ITS Global Engagement Office on Promotion and Mobility. To Bu Oin, the time is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Good afternoon, ladies and gentlemen, and my beloved students. I would like to give the warmest greeting to our speaker today, Professor Sambit Datta, the Dean of International Faculty of Science from Curtin University, Australia, And to our today's moderator, Dr. Warma Dewanti, the head of Research Center for Infrastructure and Sustainable Environment of ITS, and also all participants of this event. It is a real pleasure for me to welcome you to the guest lectures series on Sustainable Development Goals, or GLS SDGs. GLS on SDGs is a breakthrough that ITS launched as a response to the pandemic. Since physical mobility is limited, even restricted for some period of time, we decided to bring the world to ITS by inviting world-class professors to teach at ITS. At the same time, we open opportunities for international participants to join this program that will be held every Tuesday afternoon. We hope to sustain the international learning environment in which international lecturers, researchers, and students could mingle and network. GLS on SDGs is even more special. It is our commitment to contribute towards UN Sustainable Development Goals, or SDGs, and we are grateful that this semester we could contribute to 14 out of 17 goals of SDGs through this event. We are glad that GLS on SDGs can be a platform for ITS to synergize with our international partners as a collective effort for humanity, for the planet, and to ensure prosperity for all. I encourage you to participate actively in this guest lecture and absorb a lot from Prof. Sambit Datta, the expert in computational design, urban science, architecture, and many more. We are truly delighted to have you at ITS and enjoy the lecture.
Thank you very much, Bu Oin, for the opening speech. Okay, before we go to the next agenda, let me introduce our moderator. Our moderator is Bu Warma Dewanti. She is a lecturer in Environmental Engineering ITS and also head of Center of Research for Infrastructure and Sustainable Environment ITS. For education, she has studied in Environmental Engineering ITS for bachelor degree, Environmental Engineering ITB for master degree, and in Chemical Engineering NTUST for PhD. Her expertise is in solid waste treatment, and she has research collaboration with IRD France and Hanoi Architecture University and Institute for Global Environmental Strategies, Japan. Without further ado, let's proceed to the main agenda. To Bu Warma Dewanti, the time is yours.
Okay, thank you very much, Fitria. And also thank you very much, Bu Oin. Ladies and gentlemen, all of the participants, good afternoon, everyone. Okay, so welcome again to this session, the first session for GLS in ITS. And today we are very lovely to have my friends, Professor Sambit Datta. Professor Sambit, are you already in here, right?
Yes, I'm here.
How are you? Already
good,
maybe 1 year I met with you previously in Curtin University, right?
That's right.
Yes.
Good to see you, Ibu.
Good to see you. So Professor Sambit Datta will be talk today about the climate change and addressing about the climate change with spatial, environmental, and technology innovation. And this is the CV for Professor Sambit Datta. The current position is Dean of the International of the Faculty of Science and Engineering at Curtin University. I met Professor Sambit in his office last year. And also he has an award about the Michael Fentress Memorial Award, Institute of Classical Study, Cambridge University, and has an expertise. Is this maybe a little bit surprise for you, but it's not surprise for me because I call it Pak Sambit. Okay, Pak Sambit has a mix about the computational computer. I mean the computational computer design, and also with the built environment. And he's also talked to me many things about the history, about the architecture, and I hope that today we learn a lot from Pak Sambit regarding to the climate change. So Pak Sambit, the time for your presentation will be 1 hour, then continue by question and answer by the participant. And for all of the participant, as mentioned by Fitria previously about how you can ask the question to Pak Sambit, so please follow the rule. So Pak Sambit, the time is yours. You can share your material from your side. Thank you.
Thank you, Ibu Wawa, for the wonderful introduction. It's a wonderful opportunity, and thank you to the organizers of ITS to prepare the Global Learning Lecture Series, GLS, in this time when we cannot travel. And I'm very pleased to be able to share with you one of your Tuesday afternoons, and I hope you are able to engage with globally with many other researchers as well. So today, before I start, I'll share my screen with you so you can actually see. I prepared a presentation and hopefully it's full screen. Yeah. I was very happy to speak about this topic because it's very close to my heart, if not my research area. So when I received the invitation, I said, yes, I want to speak about the Sustainable Development Goals. And I want to talk about addressing climate change with spatial, environmental, and technological innovation. So I'm very happy to share with you some of my thoughts and research in this area. Now, of course, I've already been introduced as the Dean International, and so I won't spend too much time on this particular slide, but I had prepared to give you an introduction to some of the work that I do, which encompasses not only environmental design, but also computer science, architecture, heritage, sustainability, and urban design. So in a sense, I'm currently at Curtin University. And in a sense, being in the university is a great privilege because I can not only develop my expertise and share with students some of the learning, but also expand on research ideas. The university that I'm in currently, Curtin University, may be known to you, all of you. It is one of the top universities in the world, in the top 1%. It is the 9th largest university in Australia, and it has all the comprehensive offerings. We have about 58,000 students and 4,200 staff. And one of the interesting things about Curtin is that it is 30% are international students. We also have a number of global campuses, as you may have noticed, and we are very keen on online education as well, and a member of edX, which offers online education around the world. So today's topic, hopefully you can see the whole slide, is structured around 4 items that I want to speak to you about in the 1 hour that I have. The first, I wanted to start by saying, what are the UN Sustainable Development Goals? And then I want to look very closely at goal number 13, which is what I have been asked to speak about, which I can summarize as climate action. And specific to climate action, I want to share with you some of the data on the indicators of climate change. Now, this first part is really an introduction. It is not my own work. It is the work of the United Nations, various laboratories that deal with climate change around the world. But it is something I feel that is very important for students, especially to understand and know, because we hear so much about climate change and we hear so much about sustainable development that sometimes we perhaps don't know it enough or don't know it well enough. Once I have done the first two, I want to then move to my area of research, which is what I call here towards sustainable settlements and smart cities. And in this topic, I want to introduce you a little bit detail into my research around urban design, urban planning, and I want to share two projects. One is the city of Malé in the Maldives, which is a little island archipelago in the Indian Ocean, and our own Curtin University campus, and what we are doing in terms of sustainable settlements and smart cities, the kind of research that we do. So it will give you a good understanding about the research side or the university side of how we are trying to tackle sustainable development and climate change. And then I want to finish by talking about the next steps, the way forward, because your generation is going to have a very big challenge, and these things will need solutions. Big problems will require very big solutions. And here I want to just talk about some of the ideas around Industry 4.0, which talks about sustainability and renewables and so on. And then my pet topic, as Ibu Wawa mentioned to you, is IT and technology and data science. And then I will conclude my lecture on this topic. So that's the overview. And now I want to start with the first of those, the UN Sustainable Development Goals, the United Nations. Now, what are the Sustainable Development Goals? Many of you probably have seen them and know that in 2015, the United Nations met and created this document for 15 years of work with a target. It was like a blueprint to achieve a better and more sustainable future for all. The goals address, there are 17 of them. They address the global challenges that we face in the world, including poverty, inequality, of course, climate change, environmental degradation, and also peace and justice. So it's very, very comprehensive. And you can find this on the web, on the UN website, which is on the bottom left-hand corner that I have put there as a link, if you want to have further details about what happened. But in 2015, the UN decided that they would work towards an agenda for 2030 and try to achieve these goals. It's a very ambitious agenda. And 5 years have already passed. We are in 2020, and only 10 years remain to address some of these challenges. And as you can see from the next slide, these goals are fairly challenging and very bold and ambitious. The first goal, of course, is no poverty. That's the first goal, that we have 700 million people on the planet that live in extreme poverty. And the first goal therefore addresses this question of how do you lift these people out of poverty. So the slogan there is donate what you don't use, give up what you don't use. And this is part of the understanding of the goal that we need to be able to share. The second one is zero hunger. So a third of the world's food is wasted, but 821 million people are undernourished. So zero hunger is a goal, and we say waste less food and support local farmers. The third one is good health and well-being. And of course, in this time of the pandemic, we very well understand, vaccinate, because we don't have a vaccine, we are now stuck in our homes, in our countries, we cannot travel. And as you can see from here, vaccinations resulted in an 80% drop in measles between 2000 and 2017. The fourth one is education. Help educate the children in your community. There are 617 million children without proficiency in reading or in mathematics. So this is a big goal, education, which we are all a part of in universities. The fifth goal is gender equality. So empower women and girls and ensure their equal rights. This is a very big goal as well, because 1 in 3 women on the planet has experienced physical and/or sexual violence. The 6th one is clean water and sanitation. Avoid wasting water. So water scarcity affects 40% of the world's population. So clean water and sanitation is the Sustainable Development Goal 6. So you can all relate to some of these big issues, but I think sometimes it helps to just see them, in front of you. Goal number 7 is affordable and clean energy. Now it's amazing, but 3 billion people do not have clean fuel or technology. So half of the planet does not have access to clean cooking fuels and technologies. So what can we do to address this goal? We have to find affordable and clean energy. Goal number 8 is, of course, very, very common, or indeed you can identify with. It is create job opportunities for youth. 1/5 of young people are not in education, employment, or training. So this is a big number of people that need to be, targeted for job opportunities. Goal number 9 is, of course, industry innovation and infrastructure. Basic infrastructure like roads, water, sanitation, electricity is still very, very scarce in many developing countries. Support the marginalized and disadvantaged is goal number 10, which is the poorest 40% of the population earn less than 25% of global income. So there is a lot of inequity in the world, right? Very rich, very poor. So how do we support those who are marginalized and disadvantaged? Sustainable cities and communities is goal 11. This is where I do most of my work in my research career. And 9 out of 10 urban residents.
Hello?
Okay.
Sambit? Okay.
Yeah, can you hear me?
Yes, we can hear you.
Okay. So goal number 11, I'll talk a little bit more about sustainable cities and communities. Goal 12 is recycling, responsible consumption and production. So by 2050, if we don't change our ways, we will need 3 planets to sustain our current lifestyles. And so therefore, recycling paper, plastic, glass, and aluminum is a very responsible way of addressing the UN Sustainable Development Goals. So these are the first 12. Now, the one that I'll speak to today is, of course, goal number 13, which is how do we stop or avoid global warming, or, and one of the biggest items here is, I'm sorry, I'll come back to that, is the rise in carbon dioxide emissions by 50% since 1990, and I'll address that. 14 is about plastic, and the impact that plastic has on the oceans and marine and coastal biodiversity. Goal number 15 is to create forests, help plant trees. And here you can see that 80% of all species live in the forest. So it's very important that we create more forests rather than destroy them. Very, very important for our own life on land. And goal number 16 is peace, justice, and strong institutions. So war, persecution, conflict is a big issue, and goal number 16 addresses that. Goal 17 is about partnerships. So what does this mean? Goal 17 really is about market opportunities, jobs, by lobbying your government to boost development financing. So putting money into development and achieving sustainable development goals. So these are the 17 goals, and I just wanted to give you a quick summary so that you can look in great detail and see what they all stand for and which one you identify with most, and you can pick the one that you want to really target in your own career. Now, I want to focus today on goal 13, which is what I've been asked by ITS to talk about, to take urgent action to combat climate change and its impact. So again, as I mentioned earlier, climate change is a big problem, but what is the problem and how can we take action? It's so big, we always think that, what can we really do to limit change? But actually, we don't have to do a lot because a lot of people are working on this for many, many, many years. And there is a large amount of capacity around the world targeting the goal number 13. So what we can do is we can strengthen our resilience and adaptive capacity. What does that mean? It means that we should be prepared to not continue with business as usual, but to do everything with the notion that goal number 13, which is combating climate change, comes first. And what am I doing today, or what am I doing in my planning to address this? And how am I adapting? How is my community adapting? How is my family adapting? Are we resilient? Because we're talking about very large changes in climate. The second one is national policies, strategies, and planning. How am I ensuring that our policies take into account our, industries take into account and plan for climate change and address climate change? It's not just something that we put up on a board and talk about, but we have to adapt it. And the third one, which is very, very important for you as university students, is to improve education in the higher institutions, in schools, and awareness and institutional capacity to address this goal. We are trying to create a $100 billion green climate fund, which the idea is to raise the money from rich countries and invest this money in developing countries to help them with their climate needs and opportunities. So the fourth one is to promote mechanisms for raising capacity in these countries, least developed countries, and small island states, which will be the first to be hit by the changes in the climate, and including focusing on women, on youth, local and marginalized communities. So it's a very big and tall ask, but it's very important that we individually seek to ask ourselves how we are going to work on this. Now, we all know that climate change is happening, and obviously the reason I put together these 10 indicators is because the National Oceanic and Atmospheric Administration, NOAA, in the United States has many national centers for environmental information. This is a fantastic organization. All they do is they monitor the state of the Earth's, they monitor the state of the Earth's climate in real time, and they provide everyone the data and information on climate trends and variability. And so they have 10 indicators, and I will go through each one of them with you today so you understand better how the climate is actually changing. So this is the first one that the NOAA puts out as a graph. It's from 1850 to 2010, 15, maybe 2015. And if you look at the land surface temperature, some of which has been measured right from 1850 since records began. We don't have records before 1850, but if you look at it, you will see the different measurements right across the different research groups that look at it. You can see that the temperature has gone, has risen by 0.8 degrees, if you will. If 0 is a benchmark around between 1850 and 1880, it was fairly, low, but it's risen by almost a full degree. It has fluctuated a little bit, but if you look at the trend, you will see that there are these fluctuations because of different events, But overall, the trend is upwards. Now, this is fairly significant because although the temperature has risen by 8 degrees or 0.8 of a degree, or about a degree, let's say, it's not much. If it's 20 degrees or 21 degrees, you think, well, what's the difference? But we know, and scientists tell us, that a 2-degree change is about what we can withstand. But if we do not limit our change to less than 1.5 degrees, the planet will change as we know it. And there will be, more drought, more wildfires, destruction of more severe storms, destruction of arable land, rising water levels, and so on. So we know that this is a very, very important benchmark, and we can't ignore it. But we can't change the temperature of the planet without making significant changes to the way in which we currently live. Now, this is a very interesting one. The marine air temperature, this is the temperature over the oceans, is a lot less than the temperature over the land, as you can well understand. And this has also been recorded from about 1855, 1860. So we have a record of 150 years. And here again, you can see that there is a change of about 0.8 of a degree from about minus 0.4, which was, and then going up to say, 0.6 of a degree or 0.8 of a degree. So this is also a very concerning matter because the oceans are even more fragile than the land. So overall, we can surmise from this that the temperatures are rising both over the ocean as well as over land. Now, this graph shows you the sea ice. So how is this measured? It is done by looking at satellite photographs. And obviously, you cannot have, the information is only from about 1955, the Arctic ice, sea ice extent. And this is measured by studying the, looking at photographs of the Arctic Sea and seeing how much ice there is by measuring it. And you can see that it's quite dramatic, the change in Arctic ice in the first, 1950s to 70s. It was fairly even around the square kilometers. This is the extent, 10 to the power 6. So it's 1 million square kilometers, about 9 million square kilometers. There is change because it changes every year, melting and freezing. But if you look at this trend, it is actually going down quite significantly. So from about 10 million square kilometers, it is now down to about 5 million. So half of the Arctic ice is gone in 60 years, 50 years. Sorry, I've gone backwards, I'll just go. So you can see this is very dramatic. And again, this tells us that the planet is warming. So if 1 degree of warming, just going 1 degree or less than a degree, can melt half of the Arctic ice. This is quite fascinating, isn't it? I mean, it's quite difficult to comprehend, but you can see the measurements and you can see how 5 million square kilometers of ice has melted. So this is something that you need to keep in mind. Not only the Arctic ice, which is in the sea, that is melting, but this is the glacier mass balance. This is a measure of what is known as the mean specific mass balance, or how much of the fresh water in the world is held in glaciers. And this has been measured from about 1940, right? Very simply, the green line. And then there have been more sophisticated measurements from 1975. And you can see all these, the red and the blues, but all of them are going dramatically down. And particularly around 2005, there has been a little bit of an uplift in the early part of the 2000s, but really dramatic falls in the glacier balance as well, which means that the amount of water which is melting into the ocean, not remaining in the glaciers, has increased or decreased. The glacier mass has decreased. So what does this do? This actually causes the sea levels to rise, because when the water melts, the ice melts, where does the water go? It doesn't go, it goes into the oceans. And therefore, this has also been leveled. The sea levels have been measured for 130 years. And this blue line, you can see that every single line, is trending up. So the sea levels are going up. And this is about 70 to so this is 190 centimeters, sorry, 19 centimeters, 190 millimeters. So it sounds like a very little amount, about 20 centimeters, or, if you're measuring it in large quantities, but the entire planet, it gives you a sense that the levels will continue to rise, right? So this is a very alarming thing for low-lying coastal areas around the world, because some of them are less than a meter above sea level. And if the sea level rise continues over the next 50 years, then we're going to see large areas of the land, low-lying land and islands being inundated, causing mass displacement. This is another record of the humidity. As you know, you live in Indonesia, how specific humidity affects your comfort, the amount of water in the air, and this is also increasing, right? And this has been measured from the 1970s and continues to show an increase and in terms of the amount of moisture content in the air, and that causes more heat to be trapped, more carbon dioxide to be trapped, and this kind of cycle continues. So this is a measure of ocean heat content, and in the ocean heat content, which is again the amount of heat in joules that is measured between 0 and 700 meters, so across the depth of the ocean, the heat is going up. Now, as I mentioned earlier, that marine life and coral reefs in particular are very sensitive to the ocean heat content and the acidity of the ocean. And we find that as the temperature rises, coral reefs die out because they can't stand the heat. They don't like the heat. They're very sensitive to temperature. So small changes can have large impacts on ecosystems. And that's the whole idea about climate change. It's not about a degree here or a little bit of ice here or there. It's about the impact that this has. And the same with the sea surface temperature is again rising. Anyway, I just wanted to give you a sense of the deep amount of study that is going on, globally mapped studies. Number of studies are continuing with a number of labs who are measuring the state of the planet, environmental monitoring. And so in terms of climate action, of course, this doesn't affect us much. This is the last one, snow cover in the Northern Hemisphere. But definitely the snowfall and snow cover of the Northern Hemisphere has also decreased over this period of time. And this is the other one that is rising, the tropospheric temperature. So the troposphere is the lowest layer of the Earth's atmosphere. And this typically has also risen substantially. So not only is the temperature rising in the land, the temperature is rising in the ocean surfaces and the marine air temperature, but it's also rising up in the atmosphere, in the troposphere, right? So it is right across the planet. It's not just in a single phenomenon. Okay. So that is what I wanted to show you first, so that you get an understanding of the challenge of climate change and why we need to have action, because we need to keep the temperature from rising, and that is going to be very difficult. But many of you would have experienced during the COVID lockdown period, the skies cleared up, the temperatures were, there were lots of stories from around the planet. The pollution levels were down. And so it also tells us that the planet has a capacity to recover very quickly. In 4 or 5 weeks, a large number of polluted cities around the world experienced clean air, blue skies. So that's why it brings us to this topic of sustainable development and climate action. And here I want to share the second part of my talk. I want to share with you what can we do and how is this affecting us on the ground. The graphs are nice, that's the science, but what happens to us as individuals? So I want to start in this particular second half by giving a little bit of a picture about where we are in terms of the move from atoms to bits, our knowledge economy. So we know that the world is going through a big shift through data, through IT, through knowledge, and through entrepreneurship and innovation. Today would not be possible without technology. I'm sitting in Australia and speaking to you about this topic right across. We are a global community. And this is what we call the knowledge economy, or the bits economy, if you like, which is not physical, it's all digital and knowledge-based. So this is one thing that is happening apart from climate. And the combination of addressing sustainable development goals and using technology has led to this thing called the smart city. You must have heard about smart cities, the smart city framework, where we try to find new ways of dealing with our problems like pollution, transportation, deforestation, and so on. So basically what we try to do, is we try to use sensors and networks to address city problems like mobility, moving around, infrastructure development, energy, comfort, and so on. And then we try to create commercialization and business models for individual cities, okay? And here we try to use, just like I showed you the environmental monitoring, we try to use the monitoring systems, autonomous vehicles, mobile phones that people have, individuals, and link them through satellite, through sensing devices, through data analytics services to the problems of the city. So why do we need to address this? Because many of our citizens live in environments like this. This is in Brazil. It's in Rio, in the city of Rio. It's what's known as a favela or a slum. And so people build themselves habitation and they make do with whatever they can get. And I'm sure in Indonesia, you have the same problem of people putting pressure on the environment because they have to survive. They have nowhere else to go. So we need to find a balance between sustainable settlements and smart cities and find a way to address these changes through design, through planning, and so on. So I now come to my topic of today in terms of the second half. And I became very interested in this problem of sustainable settlements, or top down and bottom up. And here I put to you two types of cities. On the left-hand side is a settlement in the desert, in northwest of India, in the desert, which is built without any design. It is built before the cars. So you have very narrow streets. It is environmentally friendly in the sense that, the orientation of the houses is such that you have shade in the streets. There is no artificial cooling except by passive means, which is by using the buildings. It is very tightly built, very dense. And on the right-hand side, I have the city as we know it today. This may be part of Surabaya or Perth or Jakarta, where it is planned for the automobile, right? So it's the old city versus the new city. We have two different types of living models in the environment. You remember this one? This is how people build without design. And this is probably how new cities are being built, right? So I wanted to make a contrast between these two types of cities, before the automobile and after the automobile. So you have the freeways for transportation, you have the big towers for offices or living or shopping malls, and very, very large networks of roads. And this one, obviously, you need artificial energy in many ways. You need to cool these buildings, you need to heat the buildings, you need to have petrol and fuel for the cars, parking, and so on. And you have little pockets of green. In this kind of city, which is built pre-automobile, 15th century maybe, it's designed for the human being, for walking, right? Everything is on the street. There's not much waste, Everything is very, very calibrated because resources are scarce. The city is built with local stone. If you look at it here, this is all stone buildings, very tight. And here, these buildings may have elements from all over the world. You need large supply chains. The cars may be coming from Japan, the glass may be coming from South America, the petrol may be coming from the Middle East to fuel these cities, modern cities. So their environmental footprint is huge. And so I wanted to contrast and find out what happens my apologies. I'm going backwards. I jumped a few. So I wanted to find out how cities grow and how do they become, these large energy dependent, energy intensive environments, which are simply swallowing up the planet. Of course, they're supporting us, but there are different models. And so I did a study of the city of Male, which I mentioned to you, the capital of the Maldives. It's a very interesting place, which is here on this slide here. It is only 2 square kilometers, and it is just 2 meters above sea level, which means that with climate change that I showed you earlier, once you have a 2-degree rise, in about 30 years, this city will be underwater. Now, the interesting thing is that it has a population of about 103,000, which makes it a very dense place indeed. So I wanted to find out, how did this place become from a tropical island paradise to this complete concrete jungle, which is what it is today because of the 2 different paradigms I mentioned, cities which are global, which have access to supply chains from around the world, and cities which are unique and only locally dependent. So the city of Male, it's what it looks like, is on this beautiful tropical ocean island, completely built up. The whole island is a city, right? And it sits somewhere here. You are probably in Indonesia here. I don't know if you can see this, but south of India, southwest of India, southeast of India, is this archipelago of islands, small islands, which make up, sorry, I'll go back. This one here, every time I turn, it just goes forward, okay. And so this string of islands in the Pacific Ocean, which would have been beautiful, green islands, became a city. And I wanted to find out what really happened here and how did it grow into this. So this is the capital, and this is the country called Maldives. So to give you some idea about this city, this is Male, the city of Male in scale. Sorry, my apologies. This is the island of Singapore, and Singapore has 7,200 people per square kilometer, right? This is Singapore, and this is Male in comparison in scale to Singapore. And it has 10 times more people, right? So it is actually one of the most dense places on the planet, if not the densest place. And then I compare it with Curtin University, this is my university. I'm actually sitting in a building somewhere here. I'm sitting somewhere here, or maybe here. It is about the same size as our campus, but it's an entire city built up over 80 or 90 years. So I just want to paint to you this picture of how a little tropical island of 2 kilometers in this version of events can become a high density, high stress, I guess, environment as a city. Okay, only 2 meters above sea level, 2 square kilometers. Okay, and it has diminishing social indicators, increasing crime and livability issues, but it has continued to grow. So the research problem here was to find out, how do you get from here, and so this is some of the mathematics behind the work that we did. I won't go into too much detail here, but it has to do with the network of the streets and the connections, and how the street networks grow, and that can tell us the mathematically how connected the places are and how they grow. But I won't go into too much of the detail there with the computational side, but I'll show you some nice pictures. So it started off as an old city. There was a small island, beautiful tropical island. And then as they grew, they started to reclaim land. So the first thing they did was there was reclaiming of land, and they put another city on that grid. So this is all the new city you see around here. So the island grew first by reclamation and became almost twice the size. Now, this is how we did the study. We looked at the period 1922 to 2011. We looked at the street network and how it grows. We collected data. We generated some computational maps, software analysis. We did some mathematical analysis, and we came up with some findings. So to do this, we took 6 time slices over 80 years, over a 90-year period, because we had the information on the streets and to understand how it was growing. So in 1922, the city of Male had one big road and some small roads around it. Most of them were dirt tracks. They were not real roads. So we analyzed that with our software, and we came up with some measures. In 1960, it grew a little bit. In 1979, it had explosion of growth, and it also had that recycled, reclaimed land brought back. And in 1999, it was having covering practically the whole island. And in 2011, these roads became extremely dense and busy. So this was basically the study of the street networks of Male. So I won't go into too much detail because it's mathematical, but let me show you some pictures. You can get a better understanding. So here is the land reclamation process shown in black, and then the street formation, which I described to you, some examples of how these streets form. But if you look at a 3D model, you can see that it was going 1922, 1960, 1979, and then 1986, 1999, and 2011. So what actually happened was that when first of all, there was one big plot, right? Sorry, it's shifting around. One big plot. And then this plot became smaller and smaller and smaller. And then after some time, you could not cut the plot any smaller. So you start to stack. So you build buildings one on top of the other. And so you get the density from high rise. And you see this phenomenon in every city. Every city grows like this, whether it's Surabaya, whether it's Jakarta or Perth, we all have the same process. First of all, you have a plot and it's subdivided. You have a street network, and then the plot subdivision stops and it's more, valuable. You create your own land by going up and stacking. We call it stacking. right? So you start with a 1 story, then you might go to 2 stories, then 4 stories, then 20 stories, then 100 stories, right? So this is the phenomenon. The interesting thing here is that you don't notice it as much in Surabaya or in Perth because there is a lot of land around us. But in Male, they don't have any land. They're surrounded by ocean. So it becomes a big problem. They can't grow, right? So this is some other kinds of studies we did about the sustainability of these cities, urban elements. Where are the shops? Where are the eateries? Where are the mosques? You know, where are the most integrated streets? What does the street life look like? And so in our study, we found that the most active are the shops and the eateries. That's here. And I show where they are in the city. So this is where the activity is maximum, right? And you can see that these shops and eateries are only on a few streets where maximum activity is, okay, in the city. And then the next level of activity are in the mosques and schools. So they are in clusters like this. So this black dots here in this picture are schools, and these little dots here are mosques. So you have some more activity around these zones, if you like, but they're not along streets, they're along patterned areas. And then you have the southern half has practically no mosque or school. This is the new area, which is mostly commercial. And then there's one big chunk here that has no. So this was a very interesting finding. Where are the mosques and where are the schools and how are they related to the shops and where people live? And then the last study we did was on public open space, recreation space, and hospitals. And so we find that the public open space for people to go out from their homes is on the edges, of course, near the ocean. You know, these are public open spaces on the east and the periphery. Inside the center of the city, there is almost no public open space, nothing, only streets and buildings. Recreation facilities, we find some, you know, around the significant chunks are mostly along the main street. The old areas are, you know, showing the health and so on, the hospitals. So by looking and studying the city like this, we can find out, you know, where people are moving, where they are living, what kind of living do they have, how do they function, and we can, you know, address some of their sustainability issues around transportation and movement. So again, this is a plot, a subdivided plot, and it starts off with a building like this, has a density of 2, and then in just over 90 years, it becomes like this, with a large building, lots of people. And so it puts a lot of pressure on the blocks themselves, right? So here is the last slide in this presentation. Just to give you an idea, we studied from 1922 to 2011 how this city is growing and where its activities and functions are and how the streets are functioning to figure out, you know, how to improve their lifestyles. So by looking at all this, we were then able to suggest 2 options to improve, to take away and remove some of the streets, to make them into public open spaces, to extend some streets, to make them better integrated by using some of our mathematical models so that it would function better. So that was Male. Now, Curtin University, this is the second one that I want to run through very quickly, is also trying to become a sustainable campus. And we have a master plan for 30 years to become a green campus, zero emission campus, with, you know, maintaining our green pots. So this is the vision. So we will try to maintain the green spaces and the water bodies and try to build a major street and also new buildings in addition to our existing buildings, by following some of these rules of how people behave in cities with shops, eateries, restaurants, mosques, or places of worship, schools, and how do you configure them to get the most optimal, most sustainable configuration for a city. So this is some of the early stages of planning. We have our old buildings. I'm actually sitting in, this building here. And this white that you see here are the new proposed buildings. And the green that you see is trying to weave through and maintain some of the greenery and the urban cover. So to do this, we built a digital twin. We call it a digital twin. So we built the campus model. This is a virtual model in a game engine, sorry. We built a digital twin of the campus, including every tree, all the green areas, all the, sorry, why is this jumping? And also we found out about the energy use and the solar radiation and so on. So we use this digital twin to plan the city and to see how to make it more efficient, how to make it manage the building, the envelopes, the tree canopies, the campus assets, the streets and paths and topography. So this is using technology to try and improve the sustainability outcomes of our built environment. And so we utilize this technology to do that. The other aspect is the fact, which is energy, right? And to generate energy, we look at the roofs of all the buildings to see how much solar energy is falling on the roofs. And we track this and estimate it for generation of power on the rooftops. And we also have low power sensors to measure carbon dioxide, nitrogen, nitrous oxide, PM 2.5 particles and so on. All these particles matters in every building to try to understand, what is the quality of the air? And if it changes, we try to ask, why does it change? So we can use technology and smart technologies today very cheaply to find out about the environment. We don't have to wait for the very large and expensive items to do that. We can start with very low power, simple technologies to create that. So the next steps for us with the two projects that I showed you very quickly is to leverage our capability in 3D platforms for infrastructure development. Because we believe that if you build a model, like, for climate science, we would never understand climate if we didn't have a model of temperature, model of the weather. It's very important to build models, right? And so for us, 3D models of the cities is very important. We also want to take our research to the local state authorities because they make the decisions. We are only researchers for spatial planning, data science, visualization, and try to build partnerships with them and say, look, why don't you use some of these modeling, some of the research and data? Why don't we work together? I think this is a very big element of our research. And then the third one is not just to leave it in the laboratory, but to develop demonstration projects like we have done with Curtin Smart Campus. We want to do smart cities and smart sensors. So the project can be as small as just putting a few sensors so we can get an understanding of how much pollution there is on campus or in the building. And how is it coming? Where is it coming from? What is causing it? And try to address that. So these are I will stop there. So the last item I want to say is, Industry 4.0 is really about leveraging technology, sensor networks to address some of our big sustainability goals. And I have 5 minutes, so I will stop and say thank you.
Thank you very much, Pak Sambit. So very interesting talk. Okay, so I saw that from the first, you mentioned about the challenge of the climate change and also regarding to the smart city framework and also the problem with the sustainable settlement, because right now we have a big problem during this COVID-19 pandemic, about the sustainable settlement also, and also some innovation and research that already conduct in the Curtin University that can be adopted in ITS also, and also work together with us, try to develop like a sensor and anything that regarding to develop the sustainability. Thank you, Pak Sambit. And there's a part of the, after that is will be a question and answer, and then we already have several questions to you. So the student is very interesting to talk to you about some question. I will be read the question, and then maybe if after that, if you still have any question to Pak Sambit, because I think we have maybe 15 minutes to discuss. Okay, so for the first question from Amastasia Salsabila Mulyawati. So Salsabila asking about the livestock give a big contributor to climate change. Why does eating meat affect the climate change? So you can answer the question, Pak Sambit.
Yes, it's a very, very good question. You know, livestock is a big contributor because of the emission of methane, right? So, and it's not to do with eating meat, it's to do with the way we farm livestock. So we create very large bodies of livestock. If you look back in the traditional patterns, people still ate meat, right? I would assume, you know, but they had livestock of a very different kind. They farmed it in small scale. They lived, you know, on the farm. They were not farmed in this enormous, gigantic, mass scale, industrialized livestock. So my problem, as I mentioned to you, is not with the meat eating. That's fine, as long as it's sustainable. You can have a sustainable model for that. But if you are doing it at industrial scale, that's where it becomes a problem, you know. So for example, in New Zealand, you have 5 million people who have 60 million livestock, right? And this is not sustainable. You know, it can be a very beautiful country, but we have, with so much of livestock, you're, you know, producing methane, and it is not sustainable to keep the costs low. But in traditional settlements, if you go maybe in Indonesia to the villages, you know, the livestock is there, right? But it is living in a community at low scale, and it is scarce resource. It is probably used, you know, very carefully. You think a lot, you know. But today, you know, the way we are doing it is industrialized scale, and you go chains and leading to this problem. So to answer your question, I would say that just because the livestock are a problem, they are not a problem.
Increasing of the marine surface temperature. Because on one of your chart, there mentions that between 1940 to 1945, the temperature is rising very significantly. What is the reason behind that compared to another years? Because one of your chart mentions about the increasing of the surface temperature, but very remarkable during 1940 to 1945. Why this is happened during that time?
So this is a very interesting point and very, very well spotted. You know, in the climate science, when you look at the data in small segments, you know, like you are doing with 1940 to 1945, we have what is known as anomalies, right? Anomaly means that when you look at a little bit of the data, sometimes it may go very up, sometimes it may go very down. And those anomalies may be because of a number of reasons. We don't know, right? In this particular case, it may have been instrumentation. It may have been El Nino effect, you know, which is finished. And then you start at the peak of the El Nino, and then after 5 years, you're at the bottom. And so the temperature going down. So you will find that the graph is always doing like this, you know, up and down. That's the anomalies. But you have to look at the trend, you know, whether it's the trend is going up or trend is going down, right? So we always try to look at large periods of data, right? So you think about the ice core, for example, you know, they drill into the ice to find the historic ice, you know, because it's very accurate. You know, you can drill down on the ice and go down. And depending on the depth of the ice is the age. So you can find the temperature there as well in the ice core. You know, you can find chemical signatures that can tell you what was going on at that time, because the ice falls, layer by layer by layer and preserves some of this material. But sometimes you will find the anomaly because something maybe got mixed, right? But you have to ignore that anomaly and you have to go for the trend. And so many times in the climate skeptics will tell you, many people question, say, oh, but today was a very cold day, so climate change is not happening because today was so cold, right? It's freezing cold. But no, you can't look at only today because you have to look at the trend, right? Maybe today was cold because there was a thunderstorm, right? Or something came through. So anomalies are a part of the science, the experiment, measuring, and you have to find the trend.
Yes, that's correct. To try to find the trend of the data, I think is a very, very important. How about the condition right now in Australia? Because in Surabaya right now, the temperature is very, very high. And the humidity, like you mentioned previously, is also very high. And I don't know why, because in another city in Indonesia, they already get rains and also flooding even in some area. But in Surabaya right now is a little bit increase of the temperature. How about the condition in Australia? Is hot or is still in the middle of temperature?
We are going into summer now, early summer, springtime. So we're coming out of winter and we are having some kind of anomalies. As you know, in the beginning of the year, we had the worst bushfire, the fire.
Yes, that's correct. Yeah.
It was terrible.
Yeah.
So we are very, very worried about this year because we are, like you in Indonesia, we will be affected by climate change, water, temperature rise, and bushfire. So I think in Surabaya, the humidity problem may be some anomaly, because I'm sure the rains are coming. But you're absolutely right, Ibu Wawa, the humidity is a great indicator because it traps the heat and you feel worse, right? Whereas 1 degree here and there, and people will say, "Oh, that's nothing," right?
Yeah.
But a change in humidity is really oppressive, as you know. So my sense is that the climate, what we are seeing already, larger storms. If you look at what is happening in California now, the fires, the very, very large fires burning everywhere and smoke everywhere. What is happening sometimes in Indonesia, when they burn the peat bogs, the pollution that is, the conditions are very similar in California right now because they're being impacted by just a small change in temperature, 1 degree. But it's hard for us to understand how is it possible, right? Because many people ask me, like, only 1 degree change and we don't feel anything if it's 20 or 21, but at the large scale of the planet, it changes the pattern of the clouds, it changes the pattern of the wind flow. And so therefore, some areas become drier and, have fires. Some areas, like you said, in Surabaya, maybe having less rain, because the patterns have changed,
Yes, that's correct. So thank you, Pak Sambit, for the answer. And then still we have from Febriana Putri. Febriana asking you about if we can contribute to reduce the impact of the climate change by using eco-friendly technology such as electric vehicle, then why do these technologies so expensive? And why don't they produce in massive way or in mass? Because it's still the technology, sometimes they mentions that the technology, that if the clean technology, they're more expensive compared to the business as usual. Why is like that one?
That's a very, very good question. The answer I can give you is that when technology always has economies of scale, right? In economics, we call it. So what that means is when very few people use it, it's very expensive, right? You think about the phone, right? Smartphone, for example, when it first came in the market, very few people had a smartphone because it was expensive. But today, everybody has a smartphone. Most people have a smartphone. And there are different categories, very expensive ones, not so expensive, and very cheap ones, which have the same functionality. So more people can adopt it. And it's the same with solar power, renewable power. Not enough people have adopted it yet. So it's a chicken and egg problem. So as more and more people use it, it'll become cheaper and cheaper because more and more people will be, products will be produced. And so the price will drop as people, and there'll be a crossover. So at some point, I didn't show today the graphs of the solar energy side. Let's take the example of solar power. When I was a student like you, solar power was impossible. It was too expensive, right? But as people started putting panels and farms and on the roofs, like we are doing, there was more panels being manufactured, and therefore the price started to drop. And today, solar power has dropped by 85% the price. So it's cheaper to make power from the sun than it is by burning coal, right?
Yeah.
And yet, if you go to Indonesia, for example, as I do very often, I was there because Ibu Wawa invited me to Jakarta last December.
Yes.
We had Professor Nair, Kem Nair, and it was shocking because, the whole country has less solar power than one city. Perth has more solar power than the whole of Indonesia.
Yeah.
Right. And so it was so somebody will see this as a business opportunity and they will say, okay, let's work towards it. And then the price will drop. It's the same with electric vehicles. There are two components of electric vehicle. One is the electricity, which can, charge. And the other one is the battery, right? So now the battery is still very expensive. They can, the electricity price can go down a lot, can be cheaper than petrol, and can, drive literally everywhere. But you don't have a good battery charging, station. When you run out of fuel in your car, you can drive to a gas station. You don't even think about it, right? It's like just, oh, my fuel is less, go to the gas station every 200 meters. But electric charging now will need to have the same kind of support, and we are doing research on hydrogen. We think in Curtin University, we think that hydrogen will be the fuel of the future. Because when you burn hydrogen, you get water, right? It gives up, there's no emission at all.
Yes.
And so we are trying to produce green hydrogen from solar electricity to put in the bottle and store the energy so we can run the car. So the answer to your question is that it's economies of scale. The brave ones will pay more because they believe in this electric car technology. I was talking recently and I thought, oh, it's still too expensive for me to buy an electric car. It's too expensive in Australia. But some people are already driving it and therefore they're creating that market. They made the shift because they don't go to the station anymore, petrol station anymore. And gradually, more and more people adopt it. And then suddenly a majority of people are driving electric cars. And so then it will change and then the price will drop.
Yes.
Same like your mobile phone.
Yeah. Yeah, it's correct, Pak Sambit. I'm very agree with what you say, especially for the solar panel right now in Indonesia also. As you mentioned previously, it's a very limited use in Indonesia, but I think the local authorities also, like you say, we are the researchers, but then if you talk about this with the local authority, if they have some regulation how to use this one, I think will give a best result about this one, because the local authority has a responsible also that work with us and then also goes to the community. And then the business model for the solar panels we will try in ITS especially, because we will go to Pasuruan, other city in East Java, and then try to build like a business model for the solar panel. Hopefully that is also can be one of the model that can be adopted by another city in Indonesia. Okay, Pak Sambit, do you have any last comment? Because we already be left for 5 minutes. And then maybe you can encourage the participant in here that mostly are our students, and then they will be mostly is our next generations that will be work in this world, and also how to maintain the sustainability in this world. So please, Pak Sambit.
Oh, thank you, Ibu Wawa. I only have one thing to say to the new generation of ITS students, and the same for Curtin students, is that, your defining problem will be climate change. So anything that you do, anything you do to understand the problem and address it, not only will you be very successful in your careers, you will find many jobs because that's where all the economy is moving. I didn't show the slide, but the green transition, we call it. So green jobs, green products, green materials, everything green is going to be the future. So make sure that whatever area of you are studying in engineering or in planning or architecture or wherever you are, you have a good understanding of climate change and climate action. That's all. All the best to you. And thank you for having me.
Thank you very much, Pak Sambit. So very interesting talk today. And I hope that all of the participants can get some information from you, and also we can work together, okay,
Yeah.
for the problem about the climate change, okay?
Yeah. I just want to add one more thing,
Yes.
that Ibu Wawa and myself, we are working together already
Yeah.
between Curtin and ITS. And as you know, and we would love to do more with the students and send our students to ITS and so on. We are exchanging many ideas.
Yes,
So
yes.
thank you for that, Ibu Wawa. Thank you for your support.
Yeah. Thank you also, Pak Sambit. Maybe next time you can come again to ITS if the pandemic is already over.
Absolutely. I look forward. Yes, and I invite you to
Yes.
join us here too.
Yeah, thank you. Thank you very much. And I give back to Fitria as a MC today. Thank you very much, Pak Sambit, and see you next time, okay?
See you. Bye-bye.
See you.
Thank you.
Bye. So I give
Yes.
back to Fitria. Thank
Yes.
you.
Okay. Okay. Thank you very much, Mr. Sambit, for the excellent lecture today. And thank you, Bu Warma Dewanti, for conducting this amazing session. Furthermore, we would like to present a certificate awarding to Mr. Sambit Datta as our speaker and also to Bu Warma Dewanti as our moderator today. Okay.
Thank you.
Send it
Thank
to
you.
Professor Sambit to Kertin, Uni.
Thank you. Thank you so much. Thank you.
Thank you.
Thank you, Triya. Very nice. I appreciate it.
Okay, this is for Bu Warma Dewanti.
Thank you. Thank you, Bu Oyin and Fitria also. Thank you.
Yes. Okay, before we end our lecture today, we invite you all participants as well as the honorable speaker and moderator to take a group photo. So for the participants, please open your camera.
I think it's
Okay.
a lot, 150 participants.
Oh my
Yes.
goodness, that's a lot.
See? Amazing.
Okay.
Wow, that's a lot of people.
Yes, a lot of people, 150. So this is a blast from the pandemic because we can meet with using this kind of technology, right?
Amazing.
Okay, I will count right now. Ready? 1, 2, 3. Cheese. Okay. Once again. 1, 2, 3. Cheese.
How many layers, Fitria?
4. 4 layer. Okay, we have taken a group photo. Then for the participants, please fill the feedback form through the link bit.ly/feedbackgls that you can also see on the Zoom chat room. The deadline for filling the feedback form is today at 5:30 p.m. in Surabaya time. We want to remind you, the participant who will get the stamp is the participant who come on time, join this event until the end, and also fill the feedback form. And we have important information for you. Due to Mr. Prof. Pin Chuan Chen cannot be speaker in the next GLS SDG on Tuesday, 6 October 2020, So the lecture will be delivered by Mr. Muhammad Fotohi from University of Glasgow, UK. Okay, finally, we have reached the end of today's guest lecture series on SDGs, and we sincerely apologize for any mistakes we may have made in presenting as Master of Ceremony and Committee. Thank you very much to Bu Oin, Professor Sambit, Warma Dewanti, and all participants for the attention and cooperation. We will see you in the next guest lecture series on SDGs. Good afternoon, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much for everyone. Thank you. Pak Sambit, thank you very much.
Thank you, Prof.
Thank
Sambit.
you.
Thank you, Bu Awa.
Thank
Prof.
you.
Sambit.
Thank you so
Bye.
much.
Thank you,
you.
Professor.
Thank you. Bye.
Bye-bye.
Thank you again for all the participants, and don't forget to fill the feedback form. And for the participants who have another agenda, you can leave the Zoom room. Thank you.
Thank you, everyone. Thank you, Fitria. You did a good job. Thank you, all the committees. We did well for the first one. Yay!
Teman-teman kita.
Selamat teman-teman ya.
Berapa detik?
Thank you so much.
Kita end meetingnya in
Monggo.
3,
2, 1.
Again.